here's something you probably never thought about. Why do planes flying from the US to Asia often take a detour over Alaska instead of crossing the Pacific Ocean directly? It might seem like a glitch in the system, or maybe you've stumbled upon some secret Caribou Express route. But no, it's not a mistake. And the reason behind this strange route is far more fascinating than you might think. At first glance, you might assume it's a safety precaution. After all, the Pacific Ocean is vast. It's the largest and deepest ocean on Earth. If something were to go wrong mid-flight, a pilot wouldn't have many options for an emergency landing. Alaska, while not overflowing with international airports, is a much safer bet than the middle of a bottomless ocean. So yes, safety is part of the equation. By the way, subscribe to my channel so you don't miss any updates. When planning routes, airlines and pilots often choose paths that maximize the number of airports within reach. Emergencies are extremely rare, but in the unlikely event of engine trouble or another issue at 30,000 feet, having a backup plan is essential. But here's the thing, safety isn't the main reason flights don't go straight across the Pacific. The real answer? It's all about efficiency, saving time, fuel, and ultimately money. Airlines are businesses, after all, and their profits depend on how quickly and economically they can transport passengers. People also want to get to their destinations faster, so it's a win-win. But then why does the flight path look like a giant curve? Shouldn't the fastest route be a straight line? Well, not exactly. The problem is that we're used to seeing the world on a flat map, but in reality, the Earth is a sphere or close to it. This means that what looks like a longer, curved route on a 2D map is actually the shortest path in a 3D space. Let's break it down. Imagine you have a globe, or picture one in your mind. Stretch a piece of string between Los Angeles and Tokyo, and you'll notice something interesting. The string curves upward toward the Arctic. This arc, called a Great Circle Route, is the shortest distance between 2 points on a sphere. So while it looks counterintuitive on a flat map, this upward curve actually saves both time and fuel. But wait, there's more to it. Earth isn't a perfect sphere. It's slightly wider at the equator due to its rotation. Think of it like spinning on a merry-go-round as a kid. Remember how the force made you feel like you were being flung outward? Earth's rotation creates a similar bulge around its middle, adding about 40 extra miles to its circumference at the equator compared to the poles. This means that curving northward not only follows the shortest path, but also avoids flying through the planet's widest point. These two factors, the Earth's curvature and its equatorial bulge, are why flights often take polar routes instead of flying straight across the Pacific. Now, does this mean planes never fly over the Pacific Ocean? Not at all. Flights to Australia, for example, have no choice but to cross large stretches of open water. However, even on these routes, pilots carefully plan to avoid unnecessary risks, such as severe weather. Thunderstorms, for instance, can extend up to 60,000 feet, making them impossible to fly over. While modern aircraft are designed to handle turbulence, extreme cases can still cause injuries if passengers or crew are thrown around the cabin. So, here's a pro tip. Always keep your seatbelt fastened, even when the sign is off. Interestingly, flying over the ocean does have its perks. The air over water is typically smoother than over land because water distributes heat more evenly than soil. This reduces turbulence, making for a more comfortable ride. Another key factor influencing flight paths is the jet stream. These high-altitude air currents, found near the top of the troposphere, can dramatically impact travel times. Jet streams flow west to east and can reach speeds of over 200 miles per hour, especially during winter. Flying with a jet stream can shave hours off a trip, but flying against it can slow a plane down significantly. However, jet streams come with risks. Clear air turbulence, which occurs along the edges of these streams, is nearly impossible to predict and can be much more intense than regular turbulence. One notable incident occurred in 1997 when a plane flying from Tokyo to Honolulu hit a patch of clear air turbulence, causing it to drop suddenly. While the pilots regained control, many passengers were injured because they weren't wearing seatbelts. This is why flight plans must balance efficiency with safety, carefully considering factors like jet streams, weather, and emergency options. The goal is to find the fastest, safest route for each journey. So, next time you're tracking your flight path and wondering why your plane is taking a detour over Alaska or curving toward the poles, remember, it's not random. It's a carefully calculated decision based on physics, geography, and economics. If you found this video insightful, don't forget to like, share, and subscribe for more fascinating content. Thanks for watching.